Hi, and welcome to the probability distribution day 7. Today we're going to work with some applications with normal and standard normal distribution. And let's get started. You may be given a cumulative probability and asked to find the mean if sigma is known, the standard deviation if mu is known, or both. When you're asked to find both is when we will have to use the simultaneous equations, and you will be able to use Polysmalt 2 on your calculator. So the first problem is sacks of potatoes with a mean weight of 5 kilograms are packaged by an automatic loader. In a test, it was found that 10% of the bags were over 5.2 kilograms, and use this information to find the standard deviation of the process. Well, I like to draw a picture. I know that my mean is 5, and at 5.2, this is 0.1 because it's 10%. Now, we need to use our z-score because it asks us to find the standard deviation, and our z-score is the only thing that has mu and standard deviation in it. So it is z equals x minus mu over sigma. Okay. Well, that looks terrible. Hang on. Okay. Now that that's cleared up a little bit nicer, we have to find a z-score to help us convert to some extent. We're not actually going to find the actual z-score, but we're going to use this formula. And we know that x is 5.2. We know mu is 5. And we're looking for the standard deviation. Now, z, we know the area is 0.1. We know that the inverse norm only gives us areas below a certain value or less than a certain value. So all my yellow is 0.9%. And we don't actually have a z-score. We don't actually have to find the real z-score. We can find the inverse norm, which will give us the z-score. So we can put the inverse norm over on the left-hand side, because essentially that's what we're going to do. And we're going to do the inverse norm of 0.9. INV capital N ORM of, I have to use the yellow, which is 0.9, equals this 5.2, which is going to be 0.2 over sigma. So on my calculator, I'm going to do inverse norm of 0.9, 0, and 1. And remember, I said that if you don't put the 0 and 1, you're doing the inverse norm on a standard normal curve. It doesn't really matter. When I put that into the calculator, I would get 1.28155. I haven't simplified it yet because we don't simplify it to the n, and we need to do 3 sig figs. So this is equal to 0.2 times sigma. So essentially, I'm just going to cross multiply. And when I do that, I'm going to end up with, because that's over 1, 0.2 equals 1.28155 times sigma. I'll divide by 1.28155. That's going to cancel out. So we're just going to have sigma and whatever 0.2 divided by 1.28155. And you could keep on going because it does continue on in the book, is going to be 0.156. Okay, and that's all that we were looking for. All right, the next problem. Excuse me. A manufacturer does not know the mean and standard deviation of the diameters of the ball bearings she is producing. However, a sieving system rejects all the ball bearings larger than 2.4 centimeter and those under 1.8 centimeters. It is found that 8% of the ball bearings are rejected as too small and 5.5 as too big. What is the mean and standard deviation of the ball bearings produced? Well, let's just kind of look at this. We'll let D equal the diameters of the ball bearings. So D is distributed normally with mu and sigma, which we don't have yet. I'm going to draw a picture to kind of help me get focused. We don't know what the mean is. We don't know what the standard deviation is. We do know if we have (1.8) and then 2.5. Sorry, 2.4. My bad. We know these areas. This area is 0.08, and then this area is 0.055. Because we know that the probability of it being under 1.8, so it's less than 1.8, is equal to 8%, which is 0.08, and the probability of the diameter being too big or greater than 2.4 is 0.055 because it is 5.5%. All right, we need to find mu and sigma. So our z-scores are x minus mu over sigma. And in this case, if I take the left-hand side first, z is going to be an inverse norm problem. Okay, so it's going to be the inverse norm of On my left would be 0.08, because it's only 8%, 0.08, and my mean is 0, my standard deviation is 1, equals x, which is the number on the line, 1.8, minus mu over sigma. And for this side on the right, we have to use the 1 minus the probability. So I really need to have everything here that's yellow. So this would be 0.945. So I'm going to have to do my inverse norm of 0.945, 0, and 1 equals 2.4 minus mu over sigma. So now I have two equations with two unknowns, essentially. I'm missing mu and sigma from both of them. And I've kind of found that the easiest way to do these is to literally just cross multiply. So put that over 1, and I will get 1.8 minus mu equals, this is going to be some kind of crazy number, but I'll put it into calculator, and I will get negative 1.40507, and since I'm cross multiplying, that'll be sigma. So if I get all my unknowns on the one side, I will have 18 equals negative 1.40,